Hey class, welcome. This is James Graves and this is the IPv4 cheat sheet. This should help you out with some subnetting issues and problems. Um, this is meant to be a reference, a quick reference that you can use, not meant to be your brains. Do yourself a favor. Don't use this chart as your brains of subnetting. Understand how to determine seeder values. Understand how to determine what that does host-wise. Understand your bit values, your subnet you can create when you adjust and borrow bits. Just don't use this as your brains and the sole knowledge that you have around subnetting. It will do you no good. That will come back to haunt you in the end. I want you guys to all exceed and excel and do very well. This comes into play if you have to sit down and go take a CCNA test, and you're going to get 75 questions where 70% of them are going to be absolutely subnetting related, and you have to come up with answers quick. This is to help you out from a speed standpoint, okay? Writing this chart can also, in some sense, help teach you subnetting, at least remembering the patterns that we're going to be talking about, which will always make it a more pleasant experience because completing subnetting will then be it'll work a little quicker for you. You'll speed up the process, okay? But this is the plan for this. This is what I want to do. First off, I'm going to explain how to use this chart in terms of practical subnetting and setting things up. I also, once we go through a couple examples here, like maybe a class B and a class A or something like that, we're going to do the bigger ones. I think C's are pretty easy to get, so we're going to stick up here in the A's and B's. But I want you to also go through and recreate this with me. We have a blank Excel sheet that we're going to grab, which is, I just skipped it right here. We're going to fill this in. We're going to do it together. You guys are going to go through that and have a great understanding of how this works. So let's sit down, get running through this thing, and see what we're talking about here. All right. First off, all of these columns all have extremely relevant information in terms of networking, in terms of establishing subnets. Any of these little boxes that you see here, these little red dashes in it, you're going to be able to pull notes from that to understand something, okay? Let's look at the columns and see what's what and how they work. First off, this is simply your subnet masking information here that we need to be concerned with. This applies to these 4 octets that I placed down here, which are all subnetting octets, okay? You'll see /9, /17, /25. This is with the assumption that we're always starting with at least a /8, meaning 3, 4, 5, 6, 7, 8. Knowing your default mask values, we're always going to be here at least. 255, then something. It could be 000, it could be 255, 255, it could be 255, 255, 255, depending on what default mask we're talking about. Well, these columns, the way this seeder starts here, if we're talking a /8, this guy right here, /8, what's our next one that we could have? A /9. If we're talking B, all of these on, all of these on, we're talking a /17 because we're at a 8, 16. The next one is 17. This byte right here is the one we're referencing a bit that we're enabling. If the first 3 are on 8, 16, 24, as we referenced down here, when you enable that next bit, we are now at a /25. These columns directly correspond back to these columns, okay? If you created a /25, you have 126 hosts available, not network addresses. You should understand that you would end up with 128 addresses. We subtract our 2, our net ID, and our broadcast. This column represents host, okay? This is all our usable, okay? So any of these columns right here, this is what's usable. This is how many hosts we can place inside there. Remember, add 2 to whatever the number is, and that's where you'll find out the total number in that range. But for a class C, as an example, this column corresponds to this seeder notation. This column corresponds to this seeder notation. And then A is going to correspond to this seeder notation. Alright? Now let's see how easy this chart builds. Regardless of what octet we're referencing, we understand that these are bytes. 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. These 8 bits all correspond to the 8 bits that we have down here per octet, regardless of what octet. This isn't here to say that this is dealing with just your 4th octet or your 3rd octet. This is any octet. It doesn't matter. 1, 2, 3, 4, 5, 6, 7, 8 here. We got 8 here, 8 here, and 8 here. All right. If we enable the first bit of any of those octets, so we're starting with, in this example, a /8. We enable that first bit, it has a value of 128. Okay? What does that mean? Well, right here, 128. That's all that means. This word additive, this comes into play because this is also, if you enable that bit, the count you use when you start your next network. We're dealing with the class A in this example. So I'm going to put 10.0.0.0, which we should be able to quickly reference as a class A private. Okay? This is the entire range. And using a default mask of /8 or 255.0.0.0, we're talking 10.0.0.0 all the way through 10.255, 255, 255. But once we take this and we change it to a /9, as we did first bit enabled right here, we made it a /9, the additive is 128. Additive meaning our next network starts at 10.128.00. Why did I change this column? Why didn't I change one of these? Because this is the subnet octet we're working in. Because we're working in this second octet, that makes this the relevant octet of the IP address. Okay? So when we're going to do our additive counts, we're counting in the relative octet. So now that we understand our additive is 128 and we got the 2 networks available, why do we know it's 2? Well, it was only 2 subnets that you could have at that point. Once you divide it at that 128 mark, using that mask value, we're making the assumption that this guy here is a /9 as well. That's what's available to you at least. This guy's going to run from 10.0.0.0 to 10.127, 255, 255. This right here is your first network. This guy right here, that would be your second network, and he's going to run to 10, 255, 255, 255 as a /9, meaning we have now used up the entire class A private range. So if we enable the first bit, additive of 128, we now understand that's how our networks count. The additive is really easy because it's the bit value, so that's kind of easy to remember. How many subnets do we create? 2. What's our mask value? Well, I didn't fill that in. I didn't fill it in just because it's kind of, for me, that was just kind of always understood that that's always going to be an octet of 128 at that point. Okay. What happened if we took that same network that we're talking about, and let's say we went this route. We enabled the first 4 bits. We went from a 9, 10, 11, 12. That's where we stopped at. Well, we would make that decision maybe based off how many hosts we need, because we know that we have to accommodate 1 million hosts. We might make that based off of, well, we need to create 16 subnets out of this network of a 10, 0, 0, 0. /8 and they say give me 16 subnets. Well, we could quickly glance at our chart and understand, well, how many subnets do we need? We need 16. What does that tell us here? Well, it tells us a mask value, the additive of the networks, the bit that we're going to enable, what the seeder becomes, how many hosts are going to be available per network. And that means networks would start at 10, 0, 0, 0, 10, 16, 0, 0, 10, 32, 0, 0. Why am I just changing this column? I'm just changing that second column because, again, we are talking about this second octet of our mask. We're doing an A right now, a big network, but look how easy this is. It's all relative. Let's get this out of here. How did we get this mask value? Let's say that we did enable that real quick just to make sure that this is working, connecting dots as well. Well, we enabled 1, 2, 3, 4 bits, right, to get there. How did we get 240? We take the value of the bits that we enabled, we add them up, we spit that out. 240 is the total of all of these guys being turned on. The last bit that we enabled, that's our additive. That's how much our networks are adding by. 10, 0, 0, 0, 10, 16, 10, 32, 10, 48, 10, 64. And we keep going down the line. Let's look at something a little different. Let's do a B. Let's look at another way they may ask us a question. Right now we're starting with a /16, okay? And let's say they give us a network of 170.42. Let's say 0.0. Let's keep it default to see how this works and applies. And they say that this is a /16, okay? But they say we need you to be able to accommodate 75, let's do 7,500 hosts. All right. We could start here in this column and we could move up and we could find where 7,500 is. It's right in between here. We don't want to go low because we won't be able to accommodate the other, say, 3,500, just rounding up. So 8190 becomes it. So what does that tell us? Let's move all the way across back to the relevant column. B hosts. We're dealing with the B. We got to move to a /19. Well, 8, 16, 17, 18, 19. Slide this way. If we were to do that, we could make 8 networks this size, the same size. If we did that, we have a mask value of 224 in the relative octet. In this case, it happens to be the third octet. How many bits did we enable? 1, 2, 3. Run this across. What is our mask value? 128 plus 64 is 192. Plus 32 gives us 224. We have our mask value. We have an additive. We can get 8 subnets out of this and they start every 32. 170, 42, 32 is the next. 170, 42, 64 is our third. 170, 42, 96 is our fourth. 128. So this keeps building from here all the way down. Once we can quickly do this additive piece, look how easy it would be to find out if they said give me the broadcast address of the first network. Oh, well, I got my additive. It's got to be the address right before this. It's got to be 31.255. What if they said could 27.14 be a valid address? Yeah, He would fit right inside there. Okay? 2714 meaning 17042 2714. Okay? That's another way that this cheat sheet can help us out. So again, let's tie these columns together and then let's build one. This is not difficult to build. So regardless of what octet, we're dealing with 8 bits each time. These 8 bits have a value. Okay, the first bit's 128 all the way down to 1. Well, you can also use this same idea. If you can remember how many bits are in a byte and you remember the value that those bits have available to them, the first bit 128, and then we work our way left to right. Remember, we're dealing subnets, so we're always going this way with it. 8 bits in relation to 8 bytes and their value. This column also now becomes your additive. If you enable the 4 bits here, then you have an additive of 16. Your networks start at 16. You might reference that as your magic number. I know there's videos online that are pretty popular which reference that as a magic number, but that's what we're doing there. Okay. The mask value. Mask value becomes easy because once this first bit is on right here, we have a mask of 128. We already know this column. This column's easy to develop. So now our mask, add, move it over. Add to the next one and move that over. You take this 192, you add it to 32, and you come back and you get your new one. You take 224, you add the next one available, and you come back and you got that. 240 plus 8, you got 248. Okay? Plus 4, 252, 254, 255. And that's what you're doing all the way down. Bunch of lines, look scribbly, but I think you're following me. What else? If we enable this first bit and we had an additive of 128, we can create 2 subnets out of that. That happens if we're dealing with a /9, a /17, or /25, assuming that we're starting from the default mask. Here we're starting from a /8 and working our way down. /9 means we made 2 networks. If we started at a /16 and worked our way down, 17, 18, 19. We started at a /24 and we worked our way down, 25, 26, 27, then this is how many subnets we made. Okay. Let's say, well, before I add that, then these columns are color coded to correspond. A /9 gives you this many hosts. A /10 gives you this many hosts. Remember, this is usable. This is not total addresses in the network. There's always 2 more. There's a net ID and there's a broadcast. That is your usable. Okay. Now, let's say we started with a /8. All right. And meaning these guys were all in one right here by default. Let's make them blue so they kind of correspond. And what we did is we borrowed this way, but we borrowed 8, 9, 10, 11. Okay. Well, look, if all 8 bits were on, we understand that we've made 256 networks. Okay. What happens every time we enable another bit? This number doubles. So 256 times 2 gives us 512 if we enable this one. 512 times 2 gives us 1024 if we enable this one. Times 2 gives us 2048 if we enable this one. So if we started with a /8 and we ran it into this third octet, you know this is 256. You keep doubling for every bit. That's all we've done. We've doubled all the way across the board. This was 2, this was 4, this was 8, this was 16, till we got to here, which was 256, and then we kept doubling. We went to 512, 1024, 2048, you can go 4096, 8192. So they're going to keep going up and up and up. So you can extend this out outside of the classes that you see here. You might have to do just a little bit of math on the side to get there. So here's the deal. I want us to make a sheet real quick. I want you to see how quick and easy this can be when you begin doing this. We start in this column right here. We know our bit values. Well, we know the bits we're referencing. Well, first, second, third, fourth, fifth, sixth, seventh, eighth. We're talking 8 different bits. This first one has a value of 128. The next is half that, 64. The next is half of that, 32. The next is half of 32, which is 16. Divide 16 in half, you got 8. Divide 8 in half, you got 4, 2, whoops, 2, 1. Okay. If we have turned this bit on, our mask value in that relative octet, if we're dealing with A, B, or C, is going to dictate this here. So, but that mask value in that relative octet becomes 128. Okay. To get to this next one, you take this number, you add it to the additive here, and you're going to get your new mask value. It becomes 192. You can add straight down like this to get to the third, or if you already know this guy and you want to add 32 to it, you come back over and you can say 224. Add up the first 4 bits, what do you get? 240. 240 plus 8, we're talking 248. 252, 254, 255. Now, how many subnets are we creating if we do this? Well, if we turn the first bit on, if we went from an 8 to a 9, or a 16 to a 17, or 24 to a 25, we have made 2. We've divided the one network into 2 networks. If we go down one more spot, enable the first 2 bits, we've made 4. Again, we've doubled our networks. If we enable the third, we get 8. Double the networks. Double the networks. Look at the pattern. This pattern is kind of similar to what you already see happening over here. Okay, 64, 128, 256 if we enable that entire next octet. Now this column right here becomes kind of easy to develop because we know this is an A. We're starting with a /8 by default in an A. So this guy right here is the next possible value, a /9. This one right here is the next possible value, a /10. This guy, /11. Okay? You're going to do that all the way down until you max out the... Whoops, let's click back in there. Hitting F2 so I can edit this field. We got F12, F13, 14, 15. What happens? Why is this a /16? Well, it's a B technically at that point. You enable, if we started with a /8 and we enabled every bit in the second octet, that's where we are. We're at a /16 at that point in time, which is where you start off if you're starting with a B, okay? Which is why this guy right here is going to become a /17, okay? /18. So without boring you, let me pause and complete these. So there we go. Now all our seeders are done. So we went /9 all the way down to /32. Now what happens? A /32 means all bits are on all the way across, okay? So how many hosts do we have available at that point? We don't have any hosts available. We don't even have a network ID and the broadcast. We just have a bunch of single IP addresses, okay? We're going to do a 0 here for a /31. Why? If it's a /31, we're dealing with a 255, 255, 255, 254. And 254 means that we have 2 addresses. We'll have a net ID, we'll have a broadcast, but we will have no host in there that we can use. So this guy takes a little bit of memory. This might be the most difficult part of this chart to fill out, but here's what you're doing. Start X, 0, 2. Now from there, you're going to multiply this number. It tells you right here in this note, take this host value below this cell, multiply by 2, and add 2 to get this value. I took this one, I multiplied by 2, and then I added 2. What's 0 times 2? It's 0. Plus 2, we get 2. Now take this guy. We're going to go 2 times 2 gives us 4, and add 2. We can have 6 hosts in this network. Okay? Is that true? Is that accurate? These are networks of 8. So 0, 1, 2, 3, 4, 5, 6, 7. You take the 0 address out, you take the 7 address out, you have 1 through 6, you have 6 hosts. So this does work. You take 6 times 2 is 12, and add 2, you get to 14. Okay? 14 times 2 is 28, you add 2, you get to 30. 30 times 2 is 60, plus 2 more, you get 62. 62 times 62 is 124, you add 2 more, you get 126. Okay, so now you can either build this way, or if you want to start with a reference point and start here, what is a /24? /24 gives you 256 addresses. Okay? How do we know that? What's a 192.168.10 give us? 0 through 255, or 256 addresses. How many hosts does that give us? 254. Take 254, multiply by 2, and add 2. You're going to get to 510. Do it again here. 510 and 510 get you to 1020. Add 2, you're at 1022. 1022 plus 1022 is going to get you to 2044. You add 2, you get 2046. Okay? Keep building this guy up. Now, the completed chart, you can run it all the way up to here just so you have it all available to you. If you're doing this on the spot because you're getting ready to take your CCNA or something, I haven't seen it go much higher than this guy right here, which ends up becoming, this guy is 4098 if I'm not mistaken. 6 and 6 is 12. 4094, excuse me, ends up becoming 8190. Once you get to that spot, you should be pretty good. I have not seen questions go higher than that, so that's about what you need to remember on the fly. But the good thing is if you have to get up here and get these for the test certification, you know how. Take this, multiply by 2, add 2, you get the next value. Same deal here, same deal here, same deal here. I'll give you a formula right here too. If you're more of a math person and that helps you out, go with that. N being the value below. So 2 times N plus 2 gives you this. 2 times N plus 2 gives you this. And work your way up. Okay? Alright, from there, I think you're going to be good to go. Practice this chart. You should be able to do this on your own. When I was getting ready to take my CCNA, I wrote this chart out and I did it every morning for about a week, and by the 3rd or 4th day I was good. This was done. I had it. The 5th, 6th, 7th day was simply for repetition. And writing this guy in 3 or 4 minutes will save you so much time on an exam. But don't use this as your brains. I want to reiterate that. Use this as a resource, not your brains. Alright? Again, this is James Graves. This was an IPv4 cheat sheet. Hopefully this makes sense. If not, hit me up and I'll see if I can help you out. Take care.